Hello, everybody, and welcome to episode 74 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike. Over there is Fia and Gavin. How does it feel to be doing two episodes at once?
It feels interesting. I'm slightly tired, but we're gonna push through it because today. If you're listening to this on the day it comes out, uh, a bunch of people are. Well, not. I shouldn't say a bunch. A few people are getting here to California for my wedding. I get married on this coming Friday. So when you next hear me, I will be a married man. Uh, so
Whoa.
yeah, and that's why we're recording this ahead of time. But
That's it. We're just going to stop, real hard stop there, Gavin.
oh yeah, real hard. So
Great radio.
I kind of thought somebody was going to say something else, but that's okay.
Am I supposed to congratulate you on
Like I
getting married?
said, I'm feeling a little tired. I don't know.
I know that your fiance's parents listen to this podcast, so congratulations to them. I guess their daughter's marrying not a complete ding dong.
Oh, thanks, bud.
Yeah, that's good. Gavin, you found someone to love you bald, and that's important. Because I'll tell you what, it's a good thing you went bald. Because both Fia and I knew
it was a rough look.
It was like there was conversations that were had. Like, all right, who's going to be the one to tell them? It was rough stuff. And then when you posted that one famous picture to Facebook, that was just full beard, no hair.
Oh yeah,
it was like a tear came down my eye. Like he did it.
Oh, thanks,
good
buddy.
for him for doing it.
And you rock it too.
Oh,
absolutely.
Thanks.
You rock it.
Absolutely.
And I've only cut myself across the scalp a handful of times. Less
That's
than you would
good.
think, but when your head bleeds, it bleeds a lot.
Oh, that makes me so squeamish.
Oh, sorry.
Anyway. You
Anyway,
can keep going. It's fine.
What are we talking about today? So we're talking about...
We're talking about Gavin getting married is what we're talking about. Everything else is just,
Right, we can talk about that a little more next week after it actually happens. Even though it won't have happened by the time we record it. We're recording all this before the wedding. They don't need to know that, though. Anyway, so in episode 72, so just a couple weeks ago, we talked about the Devonian period, which was when fish first decided to walk up on land. And I say decided facetiously. They didn't decide. That's not how evolution works. But that was when fish first started walking. In episode 35, we talked about how mammals specifically got to be the way that they are. And in both of those episodes, I talked a bit, without going into like any detail, about how fish actually got from the water to the land. And so that is what we are talking about today, because it's really important. It's going to be a pretty complex episode. There will be some visual aids in the YouTube part of this episode, so if you want to go watch / listen to it there, it might help out a bit. But this is an episode where I'm going to be talking about specific pieces of anatomy that if you're not super familiar with anatomy, you might get a little lost. So if it's at all possible to do some Googling while watching this episode or listening to this episode, or just go watch the YouTube version, that probably you'll get the most out of it that way. But anyway, before we get into the meat of the episode, we've got a couple announcements. The usual kind of thing. We have some links down in the description that would make us feel really good about ourselves if you were to check out. We have all of our social medias, including the link to the YouTube channel. If you have a topic you'd like to request, or if you want to leave us a voice message about how we're doing on the podcast, you can do that with some links down below. I'm also going to reference a couple of links that I'll have down below, but I'll explain more about that a little bit later. That's pretty much all I've got for announcements. So, Mike, you were laughing quite a lot about this version of Today in History. So, what do you have for us today? I'm a little scared.
So once again, just to kind of break down some fourth wall stuff. This would be funny even regardless, but just to provide some context.
Okay.
So I am still, as we record, I suppose technically recovering from COVID-19.
Okay.
I'm still technically testing positive. I think like 9 days out. I feel fine. Okay. I did not get it as bad as other people. I'm triple vaxxed. Like I am all good to go. However, before there was an opportunity to become triple vaxxed, people had taken to all sorts of other methods to protecting themselves against COVID-19.
Oh no.
And so on this day in 2020,
No.
President of the United
Yes.
States, Donald Trump, confirmed he was taking hydroxychloroquine just preemptively to combat against COVID-19.
Oh no.
Do you remember that press conference when he was just like sitting in a room and like a reporter asked him by accident, and I think he said yes by accident?
So I have blacked out a lot of the early pandemic stuff from the government just because all of it was stupid. Like, none of it was helpful.
Yeah.
The only thing I remember was anything that Sarah Cooper parodied on Twitter or TikTok or whatever it was, where she would like lip sync to certain voice clips of him, like the one about like injecting UV radiation, which isn't something you can do.
Yeah.
Like, that's like one of the only things I remember from that time. Yeah. Anyway, thanks for
My
that,
recollection.
Mike.
I just once I came across this, I was like, oh my god! First off, that fact that that's a thing that's listed here on this website is just absolutely incredible. And second off, I mean, I feel like hydroxychloroquine kind of got a raw deal. It was the OG. It was there, and then everybody left it for ivermectin, and nobody wants to talk about hydroxychloroquine anymore.
There's probably a reason for that.
Oh, there's probably several reasons for that. So many of them, but I just couldn't let this opportunity pass. So,
oh gosh,
Gavin, now that we've hijacked the beginning of this episode, you go ahead and do your little science thing. But I loved having an opportunity to say this out loud on the podcast that I co-host.
Okay. Thanks for your segment, buddy. I appreciate it.
Yeah.
So anyway, how fish got onto land. So for this entire episode, as with a lot of things that we talk about with evolution, but particularly with this topic, it's going to sound like things happened in a straight line because we quote unquote have the answer. Like, we're at the end of the book currently. Fish are already on land. We have, the answer. But that's not how it happened. And it's really hard to present it without doing that, while at the same time not making it so complex that you lose people who are not scientists. So it's going to sound like things happened in a step 1, step 2, step 3, but that's not how it happened. I'm going to be throwing out a couple scientific names of some different, species that we have fossils of, and those are just like the ideal ones that showed the traits best, that showed the general trends best, but there are going to be lots and lots of species that I'm leaving out that were other intermediaries that had, characteristic A and C but not B, or A and B but not C, whereas you need characteristics A through Z to go from being a fish to being something that lives on land permanently. So I just want to put that caveat out there immediately because it's going to sound like that's how it happened, but it's not. Cool. So, a lot of my information from this episode comes from a pair of really good review papers from 2004 and 2009. Both are open access, so anybody can go take a look at them. The links will be down below in the show notes. Hint, hint to my grad school advisor, Darren. This is a big section of one of our classes. If you want to use
former
these
podcast guest, Gavin, correct?
You're right. 2-time former, I guess technically 3-time, because we had his voice message in there. So technically 3-time former guest of the podcast, Darren Paniak. And so, Darren, if you're listening, this would be really good to use in paleobiology. These 2 papers. So, or other concerned listeners, if you want to read these papers, they'll be down in the show notes. So, real quick reminder of fish taxonomy. Not super in depth, but just sort of how fish are divided in our current understanding of things. So, first, fish are vertebrates. They're things with bones that are on the inside of their body. They're jawed fishes, which are what it sounds like. They have an actual bony jaw compared to things like hagfish, which just have a mouth. They don't have like an actual jaw per se. Then there are the bony fishes, which, if you're thinking of a fish, that's not a shark. It's a bony fish. And then within that, there's one of the two big groups. There's the Actinopterygii, which are the ray-finned fishes. If you're thinking of a fish, it is almost certainly one of those. It's your perch, your bass, your tuna. Basically, any fish you are thinking of is one of those. The other group is the Sarcopterygii, which are the lobe-finned fishes. Today, there are 8 living species. There are 2 species of coelacanth, which we've talked about a bit on the podcast before, and there are 6 species of lungfish. And the big difference between the 2 groups of fishes are the lobe-finned fishes have lobed, fleshy fins, and the ray-finned fishes do not. That's the big difference between the 2 of them, which is a shocker. That's what they're named for: the lobe-finned fishes and the ray-finned fishes. Now, the best living example of the bones of the fins of the lobe-finned fish, the bones. So, with the lobe-finned fish, they don't just have like a fleshy fin; they have bones in their fin. And sort of the best example to look at for that would be a lungfish. So, specifically, the best one that's alive today to look at would be the Queensland lungfish. Again, if you have the opportunity to Google, please do so now. It will make much more sense. Effectively, if you're looking at the bones of a lungfish's fin, it sort of... It almost looks like a Christmas tree, like a triangular pine tree, sort of like that, where there's just sort of a column of thicker bones in the middle, and then branching off the sides, instead of going like angling down, they angle sort of up, are sort of these branches of smaller bones coming off the sides. And so that is more or less the baseline for what fish fins looked like around the time that fish started delving onto land, or at least started getting some of those adaptations to be able to do that. But something that's really important about the lungfish is that even though it's not super noticeable unless you're looking at like a labeled diagram, but it's really important that lungfish, the bone, there is a single bone at the part that meets the body, and then at the end of that there are 2 more bones. And if you look at your own arm, that is how your arm is set up. You have a single bone, which is your humerus. That's sort of your first bone from your shoulder to your elbow. And then from your elbow to your wrist, you have 2 more bones. That's how your arms are set up. And that's how all tetrapod arms are set up. Tetrapods being the land living vertebrates. Tetra meaning 4, pod meaning feet. So things that have 4 feet, or at least used to, in the case of things like snakes, those are tetrapods. And that's what we're talking about today. So, lungfish is sort of a good representative for the baseline of what fish were doing around this time. And one of the things that lobe-finned fish had, and we're not, I tried looking up exactly if we're sure why lobe-finned fish have bones in, like, what was the reason why they initially have bones in their fins like that, and why they do and ray-finned fish do not. I couldn't find a particularly good reason. It would make sense, even for things like mud skippers. So those are ray-finned fish. They do not have bones in their fins like this, but yet they crawl around on land seemingly pretty fine. So it's not like that's per se the reason.
Yeah.
But that was just one of the things that they had that sort of made this transition a little bit easier. But there's another really important thing that you need for life outside of water, and that would be lungs. It's kind of hard to live on land if you can't breathe. It's kind of hard to live in general.
Pause.
You know, life tips. Yeah.
Plants.
Oh.
Well, are we talking about specifically Animalia here? Like,
well, yeah, animals.
okay.
I mean, so to an extent, like obviously, like insects don't have lungs per se, actually at all. Insects just sort of passively absorb oxygen. They have like a system for it, but it's not as dedicated as like animal lungs are. But I mean, plants make the oxygen, so they're a little bit exempt. They still do respiration, but they can make the oxygen for themselves. So
right.
they sort of get a pass.
Where I get that, I'm sorry, just like with lungs specifically, it's a feature of like mostly large-ish animal life.
So depending on how you define lungs, if you're defining them as in like the vertebrate version, because how vertebrates breathe on land is not the same as even how like the biggest arthropods breathe on land. It's just fundamentally very different structures. But how vertebrates breathe on land is interesting. They've modified it a whole bunch of different ways. I think we've talked about a little bit before how turtles like use their liver as a piston to push air in and out of their lungs because they can't use their ribs anymore. Fun stuff like that. But anyway, we're not here to talk about turtles. So lungs are really important for being a big animal out of the water. But there are lots of animals in the water that still have lungs, or at least breathe air of some kind. Lots of fish do this, and a lot of people kind of forget that. Like, for example, goldfish are actually really good at it. If you ever see a goldfish just pop up to the surface real quick and take like a gulp of air, they're perfectly happy breathing that way instead of through their gills. This is really common for fish that live in pretty oxygen-poor environments, like swamps. Shout out to you, Fia. So,
thank you.
Swamps in general, the water in swamps is really low in oxygen because there's a lot of decaying plant material in it. And when stuff decays, it absorbs oxygen. And
also smells.
Yes, it sure does. So I'm sure that is sort of a reason to not breathe the air, I guess. But if the air is that smelly, imagine how bad the water is. So lungfish, like I said, are the closest living relatives of tetrapods, and they're called lungfish for a reason. They already have lungs, and they also have gills. They have both, and so that was sort of the default condition. So the things that eventually would come up on land already had bones in their fins, and they already had lungs. And depending on who you ask, it's sort of the more recent research is sort of leaning toward that all fish ancestrally had lungs and gills at the same time. So like the very first bony fish had lungs right from the beginning. So in ray-finned fish, though, I don't believe there are any that still retain like usable lungs, as we would call them. But in most ray-finned fish, they turn it into their swim bladder. So that's how they sort of... Yeah, that's how they move up and down in the water. They have a sac of gas. If you've ever, dissected or, filleted a fish, you probably see it. It's a little bit sort of anterior to the stomach, so in front of the stomach, more toward the head. And it's just this sac that they can diffuse gas out of their blood into. And if they fill it up, that makes them more buoyant and moves them up in the water. And if they want to sink a little bit, they can reabsorb some of that gas into their blood, and it'll make them sink a bit. And there are some fish. Yeah, go ahead.
Sorry. Fun fact that I vaguely remember learning, like last year, that some fish, when they release air from their swim bladder, will actually produce a sound underwater.
Oh.
And so I guess you could kind of say that they're farting a little bit. Which
Or would that be burping?
I
I
guess,
don't know.
yeah. It's a release of gas somehow.
No,
But
that's
yeah.
neat. I didn't know that.
Mhm.
I think that there are some species who can actually even just like go up to the surface and take a gulp of air and then push that directly into their swim bladder. That may or may not be true, but I've heard that somewhere.
Yeah, cool.
And so these features are sort of misleadingly called pre-adaptations, which isn't technically wrong, but it again sort of reinforces that notion that being on land is sort of like the end goal of evolution here, which it's just not. It seems like it is because we already have it, because it's already here, but that's not how it works. That's not how evolution works.
Yep.
So,
I just took it out.
quiz time. What are some basic challenges of living on land if you are used to living on the water?
Gravity.
Ooh.
Gravity is a big one because in the water, the water supports your weight for you. That's why things
Right.
like whales can be so big, but when they get beached, they crush themselves under their own weight. The
Oh.
water will hold you up.
Yeah,
And
that doesn't
so,
seem like a good thing.
no. So if your entire biology is used to not having to support your own weight, living on land is really hard. It was less hard for things like the arthropods because they already had legs. You know, things, like with like crabs have been around forever. So they already were used to walking. They already had the structures for that. So coming up onto land was still difficult, but they didn't have to grow new legs to be able to do that. So what else we got?
This is challenges of living on land after living in the water.
Yep.
I was gonna say like staying moist, like skin probs.
Yeah, that's a big one. Especially for it depends. There's different hypotheses about whether the fish that eventually moved onto land came from freshwater or saltwater. There's debates about it, and it's still not really totally resolved. But living in freshwater versus saltwater means you have to do very different things internally with your water. Because if you live in freshwater, you need to be getting rid of as much water as you can. Whereas if you live in saltwater, the environment is constantly trying to steal your water, so you need to retain it. But being on land is sort of the extreme version of that. And so being on land, drying out is a massive, massive problem and challenge, which is why certain groups that we have today, like amphibians, need to stay pretty moist. They never really got the adaptations to quite survive that, except for some like toads. They're pretty good at it. But yeah, the first things to come onto land from the water would have a really hard time because as soon as they hit the air, it would immediately start drying them out.
Yeah.
All right. Well, I'll get one more from the audience before I go run down my little list here.
I almost want to say sight, but I feel like that's kind of
Yeah, me too. That's what I was gonna say.
No, that's another big one. Just sensory and observing your environment and sensing your environment is a big one, just because light reflects differently in air versus water. And there's also more colors that are visible in the air versus water because water filters out a lot of light. And so being able to adapt to seeing in the air, not only that, but smelling works totally differently in the air. Most fish have what's called a lateral line system and don't really have ears. And so feeling vibrations through the air versus through the water is really, really different. And so everything about sensing your environment becomes totally different. So great job, team.
Yeah.
I feel like we did pretty well on that one.
Yeah, no, that was
Oh,
really
yeah.
good.
Remember correctly?
Yeah.
Yeah.
So let's see, just going down my list here. So just air in general, being able to properly absorb it through, to get enough oxygen.
Mm-hmm.
There is generally more oxygen in air than there is in water, even at this time where there was a lot less atmospheric oxygen than there is today. But there was still more than there was in the water. So, but you still need everything to stay moist, which, like what Fia said, air is constantly stealing all of your water. And so being able to breathe while keeping the inside of your lungs moist is a big challenge. Supporting your own weight, like we said, sensing your environment. Another big one is food acquisition, because most fish feed by suction. If they just keep their mouth closed until something gets close enough, then they just open their mouth really fast, all that water just rushes into their mouth, including things in the water. So that's how most fish feed. Just open their mouth real fast, and whatever they want to eat just gets sucked into their mouth. You can't do that in the air. Air's not thick enough for that to happen. So you need to find some other way to catch your food. Another thing is
I'm really
ion.
seeing all of
Oh, go ahead.
I'm really seeing all of the negatives about air right now. It's like,
Yeah, it's not a good place to be.
yeah, like, dang.
Another important one is ion regulation, which if you live in the water is easier to manage. Because like I said, if you live in fresh water, the environment is constantly trying to steal your ions. Whereas if you live in fresh water or salt water, the environment is trying to give you all of its ions. So you don't have as much of a pressure when you're doing that in the air. There are very few ions that you can get just by breathing. But
Are you just talking about salt?
Salt and other ions, you need to get...
Okay.
Salt is the big one.
Yeah.
But fish will passively get, potassium, sodium, all sorts of ions just across their gills. So a lot of things that are like in vitamins that you eat are also just dissolved naturally in the water. And a lot of fish will get some of that just passively by existing in the water. You can't do that in the air, so you need to find some other way to do that while also not just peeing all of it out.
Right.
Drying out, like you said, maintaining your water balance is really important. And then finally, the sun. I don't remember. I think it's history of the world, I guess. We've talked about it before, but there's the
sun
line.
Is a deadly laser.
The sun is a deadly laser. And that was true back then too, where it's like, we get sunburnt and we're supposed to be up here. UV rays don't make it very far into water. So being up on land at all means that they're being exposed to all sorts of radiation that they are not particularly well prepared for. And so these are all of the problems with coming up onto land that fish had to solve one way or another. So let's walk through some of the timeline here of how this happened, when things happened, and what sort of changes they went to solve. They had to go undergo to solve all these problems. So let's start with basically a lungfish or a coelacanth, and we're going to sort of tweak some of its stats, I guess, as we go through time. So the first steps basically involved a lot of stuff in the skull, and I've sort of heard it joked that this transition happened from the front of the body to the back of the body, because when you
I'm
when
curious
you
as to
crawl,
what that means.
well, I mean, started from the head and worked its way back. When you crawl out of the water, the first thing to come up onto land is your head.
Right.
But vastly oversimplified, but kind of. So the first steps really involve a lot of stuff in the skull. If you've ever seen a fish skull, it is very bony, as in there are lots of small bony bits. Whereas if you've ever seen like a human skull, it has much, far fewer just bones in general. And that all started kind of around this time. So a lot of fusion of different bones to become like a single bone, or just loss of certain bones, while the bones that took their place just grew in size. So just a general simplification of the skull. Those proximal limb bones, so that'd be the bones in the fins that are closest to the body, what would eventually turn into the humerus, your upper arm bones. Those just got generally a bit chunkier as, potentially more stress was being put on them. The eyes were being moved to the top of the head, which a lot of animals that live sort of amphibious lifestyles have that. Things like crocodiles, their eyes sit right at the top of their head, whereas, like your eyes are definitely not the top of our heads, or they're about halfway up the skull, or maybe even a little bit less. But if you need to see in the air while still being in the water, you want your eyes to be all the way at the top.
Mm-hmm.
The hyoid arch, which is really important for supporting the gills and things, and also in tetrapods also supports things like the tongue. There was some significant changes to that as well. Potentially, changes to how they were using their gills or how they were feeding. But by this point, still very much fish. If you hooked one of these with your, fishing rod, you would still absolutely call it a fish. This gives us a fish sort of like a very famous fish called Eusthenopteron. There's a lot of very fun names in this transition,
Really?
which is part of why I like it a lot. So Eusthenopteron was found in Quebec and dated to around 385 million years ago. Also had some unique features that may or may not have been, have shown up for the first time in Eusthenopteron and its close relatives. Things like bone marrow. Fish don't really have that. I didn't know that until doing this research. But the first evidence of bone marrow, as well as teeth folded in a really unique way, like the enamel of each tooth folded in a weird way, called labyrinthodont. Basically, it just, labyrinthodont meaning maze tooth. It's just folded in a weird, funky way. There's an entire group of tetrapods, like some of the very first tetrapods, once they actually get up onto land, called the labyrinthodonts. So that are really iconic for having that kind of teeth. So both of those first show up here. Some more advancement in some of those features happens next. So, the eyes continue to move up to the top of the head. The arms get a bit more robust. Some of the bones in them get a bit more sturdy. And this gives us a fish like Panderichthys, which is a bit different. The arm fins, the pectoral fins, were sort of now pointed down instead of to the sides, like they would be in a typical fish. And then to a greater extent, these changes would get you a fish like Tiktaalik, a very famous fish, often called a fishapod. Half fish, half tetrapod.
Wow.
Which both these are very much still fish, but by this point, this would be around 380 million years ago. So about 5 million years after Eusthenopteron. And if you caught one of these, you would for sure be able to tell that it's a fish, but very weird. Particularly Tiktaalik. So Tiktaalik actually had a neck, which I'll go into a little bit more in a second. But that is also a really big innovation. Fish don't have necks, if you think about it, because their pectoral fins are connected to their skull. So it'd basically be like if your shoulders, your clavicle, your collarbone was connected to the base of your skull. That's sort of how fish are set up. Mm-hmm. Tiktaalik is the most primitive looking fish to separate those two. Also, something that I didn't know but makes sense is that a lot of these fish have a hinge in the middle of their skull. Fish in general, because they have all of these bones, can shift their skull around a lot. And that generally helps with being able to open your mouth wider and therefore create more suction and be able to suck in more water while you're trying to eat and just provide more suction to be able to suck in your food. So if you can hinge part of your skull, you can open your mouth up just like that a little bit more, which might make a difference. So we see that in pretty much all of these fish to this point. Panderichthys had this joint, but it likely wasn't actually able to use it. The rest of the bones in the skull look a bit too stiff and aren't oriented quite the right way. So still had the hinge, but likely couldn't move it. And then we get a little bit later to a different kind of fish called Elginurpaton, where
Elginurpaton.
Right? Aren't these
so
names
many
are great?
Cool names.
I know.
I'm having fun just listening to you say them.
Yeah. But Elginurpaton, which looks fairly similar to Panderichthys, but had lost this joint altogether. So by this point, its skull was fairly solid. And in Elginurpaton, we see a lot more just continuation of these trends. The eyes further up on the skull, the nose, the nares, the actual nostrils, continuing to open up further into the mouth. Because fish nostrils are a little weird. They don't do all that much. But if you're needing to smell in the air, then they become a little bit more important. Let's see. They also have some strengthening of the hip bones, because by this point, they're able to basically just do push-ups. That's basically all they're doing with their front limbs at this point. They can't really, walk, and they're certainly not feet yet. And like I said, with Tiktaalik, and then I believe Elginurpaton as well, they actually have necks. They can actually wear ties for the first time.
Hooray!
Is that the dividing line?
So, it depends. Where would you put a tie on a fish? I've seen SpongeBob. Doesn't that like the announcer fish wear a tie anyway?
Yeah, I think so. Yeah.
Huh.
Yeah, I mean, look,
What?
I hate to think about it like this, but yeah, like that's this is a good dividing line, even though damn, it's a weird way to make a dividing line for a science podcast. But all right, here we go.
I was gonna say if you could wear a necklace, that would be the defining thing for me.
About whether you have a neck or not?
Yeah.
Or, yeah.
Yeah.
So, and it's around this point where I have to, again, talk about the arbitrariness of some of these terms. Because I personally would call some of these things tetrapods if their limbs are no longer connected to their head. Because then they have actual limbs that they can move around. They might not really be able to support themselves. But it's like you have 4 limbs, and that's what the word means. But things like Tiktaalik is not considered a tetrapod yet. Elginurpaton, I don't believe, is considered a tetrapod yet. But these next ones are pretty much just on the outside. I've heard some sources call them tetrapods, and some things call them not quite. So these are basically as close as you can get to the line without being there. So, these new things that are, like I said, right on the line, we see some features like an actual ear hole, which is called the fenestra ovalis. They actually have sort of ears for the first time. They don't, from what I could tell, have like an eardrum quite yet. But the first middle ear bone, which is the stapes, shows up. That was originally part of that hyoid arch that supported the gills. Part of that sort of split off and became part of the hearing system. A single nasal bone. So, like I said, in all of these fish, they have lots of different bones in the skull. It's now just generally becoming more simplified, but a big part of it is they have one nasal bone on each side that is surrounding the nostril. More robust vertebrae now. The limbs are already fairly robust, but you need, the backbone to become more sturdy as well when you're sort of hanging the limbs off of that backbone. We finally get some more robust development on the back limbs, including a sacrum, which is part of the vertebrae that fuse to the hips, as well as a fused ischia, which is part of the pelvis. The epipodials, which is your forearm, effectively, your forearm and your shin. The two bones in each of those are now parallel to each other instead of sort of a little off balance a little bit. Now they're parallel, like they should be in good tetrapods. And all the bones in the wrists and ankles are now bunched up in the order that we see them in later groups. They have fingers for the first time. Up until this point, they didn't really have fingers. They just sort of had, more and more looking like arms, but with just those fin rays at the end of them. But now they actually got differentiated into fingers. Still probably webbed and potentially having some of those fin rays around there as well. And that is sort of the big features here. And this includes some really famous animals like Acanthustega and Ichthyostega, both found in Greenland from around 370 million years ago. So by this point, it had been about 15 million years of these timelines here. So this was not at all just a really quick, hey, there's bugs up there now, there's plants up there now, we should go up there. A really long, drawn-out process. And these two in particular look a lot like aquatic salamanders, like newts, almost. Because like I said, they have these really flat heads with the eyes at the top. They have fingers. They have a long tail with probably like a fin on it. So they look a lot like, I had the name of a newt, one of the kinds, like an axolotl or something.
Those are cool.
Yeah, axolotls are really cool. These likely still, like I said, they had lungs and gills from the beginning. Axolotls don't have lungs; they just have the gills. These still had gills, not as like external and sort of flashy as in like an axolotl, but importantly, part of that hyomandibular sort of structure is no longer really there to support the gills like that, as well as the operculum, which in fish is the part that covers the gills so you can't see them from the outside. That is very reduced at this point. So I haven't seen any reconstructions of these two species or other related species where they have like the external gills like that. So I'm not quite sure if that's something they would have, but I think that would be neat to look more into. I didn't actually see anything about it.
I have a question.
Yeah.
So, at this point, would you say that they are kind of like mermaids and that they can breathe in both air and water?
Yeah.
Cool. Very cool.
Yeah. Well, and from the beginning, they could pretty much do that. Because like I said, they had lungs pretty much from the beginning.
Right. That's true.
Yep.
But I guess were they using them at that point?
I'm not sure.
Yeah.
I mean, that's something that's really hard to tell. That'd be like an environmental thing. An environmental thing to be like, well, these rocks look like they're from, a deeper water environment. So was it living more at the surface and taking gulps of air every now and then? That's something that's probably pretty impossible to know.
Yeah.
But yeah, so we have these things that, like I said, effectively look like just aquatic salamanders with less well-defined legs and weirdly extra toes. I believe Ichthyostega has 7 toes per limb, and I think Acanthustega had 8.
Is there any kind of advantage to that?
No.
Okay.
Potentially, like I said, these were still fully aquatic. They probably were able to come up on land, but from all accounts, it looked like they were a primarily aquatic, animals. And so, particularly with, I think, Acanthustega, it looked like its limbs, the rest of its body, like the skull and stuff, progressed along the same trend that, the rest of the, tetrapod ancestors were, but the limbs look like they almost got like sort of stunted. So it wasn't really using them to support its own weight. It potentially has been, sort of thrown around that it might have been using the limbs at this point to like hang on to seaweed and stuff. So I kind of forget what your question was, but advantages to advantages to having more fingers. So
Yep. Fingers, toes.
maybe just like using them to more paddle, wider surface area, because they were for sure webbed. Still, they didn't have individual fingers like you have. So maybe just like a wider paddle, potentially. But these were not, again, like the only ones around. There were lots of them, pretty much all around the northern hemisphere. I think there's been some evidence of them being some like cousins of Ichthyostega and Acanthustega being around the southern hemisphere as well, but most of the stuff's from the northern hemisphere. But yeah, they were very diverse and very common. And I think Acanthustega is a really good example of some traits progress differently than others, and they were perfectly content staying at the water. They had all the features to be able to go up and do stuff on land, but they were, by all accounts, still a very aquatic animal. After that, we get some of the first true tetrapods, because like I said, those ones are kind of on the fence. But one of the first true tetrapods would be an animal called Tulurpiton. And generally, this is considered, like I said, one of the first tetrapods because compared to Ichthyostega and Acanthustega, it had much, much more mobile limbs. So its wrists and ankles were much more flexible. The joint at like the shoulder was generally more flexible, so they were able to maneuver a lot better. And so it's because of that they sort of think that this one was able to function a lot better on land, but still also fairly aquatic. Had a long tail that presumably was kind of fluked, like you would see in an axolotl or something. But by this point, potentially no more gills. It's a little debated on Tulurpiton and some of the cousins, but it is very much, I don't think we have any direct evidence for it, but it is very confidently presumed that they were breathing through their skin, similar to how frogs and salamanders do today. So they might not have had gills anymore, but they could still breathe in the water.
Cool.
In addition to those more robust limbs, they also had a lot bigger bones in those limbs with more dedicated sort of projections and things for different muscles to attach. So not only were they more flexible, but also with bigger muscles attached to them as well. So those were the first true tetrapods. And then a little bit later, in the very earliest Carboniferous period, so by this point, those Devonian extinctions that I talked about in episode 72, all of those had happened, and by this point, we have basically just the true tetrapods left. None of those fishy things that were kind of on the line, but not quite. All of those went extinct in this extinction. We're left with just the true tetrapods and the ones that are fully fish. None of the in-betweens are really left. But that gives us some of the first fully terrestrial ones where they probably still had to go to the water to lay eggs, but by all accounts probably still would have looked a lot like a reptile by this point instead of like an amphibian. These would be things like the genus Pedherpes. Again, just really fun. Which kept advancing all of those joints and strengthening the limbs. Since we're in the Carboniferous period, all tetrapods by this point have been knocked down to just 5 digits at most on each limb. And that's why we have at most 5 today, is because all the ones with more just happen to get the axe. And Pedherpes is also really important because it's the first one, to my knowledge, to show up that has its feet sort of facing forward, which just generally means that it's, that's a much easier stance to support your weight under. Next time you do push-ups, try to do it with your fingers facing out against your body or away from your body, and see how much more strength it takes to do it that way than if you have them facing forward. So by this point, just more efficient at doing things on land. And so that takes us basically to tetrapods as we know them today. But I think it's really important to also address the why things might come on land, because we talked about the challenges and how it's really hard to actually do this. And it took them close to 30 million years to get through all those changes, which evolutionarily is a decent chunk of time. So why would something that is perfectly well adapted to living on the water decide, quote unquote, decide to go up on land? So what do you guys think for those kinds of things? Any thoughts?
I'm really not sure.
This is one of those things that I've thought, like, I've never once in my life gotten high, but like, Gavin and Fia both know this. I'd be a really good stoner, just with the thoughts I have while completely sober. Like, I've thought about this so hard. Like, okay, we had like stuff in the water, and it came up on land at some point, but why? I have spent way more time than I'm willing to admit in public, except on the podcast, thinking about why that is. And this has bothered me for a while. Am I going to get an answer, or am I going to get a we don't know, here's some ideas?
So the 2004 paper that I read basically laid out 6 questions that they wanted to answer, because it was a review paper. So they just took all the available information at that point in time and put it all together and just said, this is where the state of things are at. And they basically said, we have 6 questions. The hardest one to answer is why. They're like, we have some pretty confident guesses based on what was going on in the world, as well as some of the trends that have been going on a little bit before this in these fish. And so we have some very good ideas, but it'll be really hard to ever know for sure why.
Of course.
So that's how evolution works sometimes. Actually,
so mysterious.
Most of the time. But the reason why we have some pretty confident, suggestions is because it's fairly straightforward if you think about it, if you really look at the context at the time and breaking it down. So the first one is breathing air, because like I said, yeah, it comes with its challenges, just breathing the air. But if you live in really shallow environments like swamps, water has much less oxygen in it than air does. And you can see that in a lot of like Amazonian fish can breathe air, even though they don't have proper lungs like lungfish do. They'll just come up and gulp air. And they have a specific other organ in a lot of fish. It's called a labyrinth organ. That's just full of blood vessels. They just shove the air into that, and it effectively works just as a not very efficient lung. And so they already had the adaptations to do that. These early tetrapod ancestors already had lungs, but if you don't need to be in the water, if you can be where there's more oxygen, that is beneficial.
Right.
Limbs are potentially important as a reason for why you might want limbs and be able to, use limbs as one of your modes of locomotion. If most of your predators live in the water, being able to just throw yourself up on land without dying is a pretty big plus.
Yeah, that seems like a good thing.
Oh, so yeah.
I mean, it's similar to like you. If you're in the water and you see a shark coming after you, you want to not be in the water.
Come on. Why you gotta go for the shark?
Okay.
What about,
if you see a killer
dolphin.
Whale, if you see a killer whale,
how about a dolphin
in the water? You're right. We're not here for shark vilification.
Right.
If you see some unwanted animal in the water, you want to not be there. And if one of your options would kill you, such as throwing yourself up onto land, it might be helpful to be able to move around up there and be able to survive up there for long enough for the unwanted thing to go away and then just slip back into the water.
That seems to me just a wild explanation. Like,
Think about it
Is it
sort
though?
of. Think about it like a frog. So if you see a frog hanging out on land, or
right?
like on like next to a pond, it thinks you're scary, so it jumps in the water.
Right.
Exact same thing.
But this, like, we're
You are
talking
the big
about
scary predator in this scenario.
In the
I
water.
right. No, like
Well,
I understand the thing, but like frogs already have the ability to be in the water. We're talking about like animals evolving that trait, like just on the basis of trying to get further away. Like that's
think about it this way. So if you are slightly better at living on land or just surviving on land, not even like living up there and getting food or anything, but say big predator comes, you can toss yourself up on land, and all of your cousins and siblings die when they do it. If you can do it and then live up there for just long enough for the thing to go away and go back in the water, you are now having kids that can do that, whereas the other ones couldn't. And so if you can better survive up on land, if you have a better chance of surviving by throwing yourself up there and evading predators, that gets selected for.
I mean
It's not
I
bad.
no I understand that, and like the train of thought makes sense. It seems to me it seems like that's a reasonably small fact. Like entire species are evolving
Right,
more
and
and more
these are
naturally.
all things that are combined. So it's not like just that is what caused them to grow legs, but it's one of the supporting factors.
Understood. Okay.
So if you're able to throw yourself up on the land and then you're spending time on land, um, you know, if you're able to be up there, you might as well. I mean, again, this is a pretty big oversimplification. If you're already up there, you might as well, start getting selected for traits that not only make you not die, but be able to actually function on land. Um, and like I said, things like mud skippers that we have today are clumsy, but they definitely function on land. And eventually, they don't really get most of their food on land, but they can. And so eventually, you know, 20 million years down the line, they might grow some legs too. So it's like, just because something, I think mud skippers are a really good sort of analogy where it's like they do perfectly fine. And a lot of these things that eventually their ancestors led to tetrapods were also doing perfectly fine. There were just some of them that might have been a little more evolutionarily ambitious than others. Um, and so a big part of why this also happened was things like there was actually stuff on land by this point to eat. So it's like if there wasn't stuff on land to support them, there would have been no pull onto land, not just the things in the water pushing them up onto land. There would have been nothing on land to sort of pull them and support them in their ecosystem on land, if that makes sense.
Yeah.
And so
Okay.
by the start of the Carboniferous period, we have these now fully terrestrial tetrapods, and they eventually would lead to the lineage that would give us all of our reptiles, and then the other lineage that would give us all of our mammals, and some side branches that would give us our frogs and salamanders that we have today. And that is the story of tetrapods. Grossly oversimplified.
Very cool.
As is our brand when we get to in-depth topics like this.
Absolutely.
Oversimplified, just to the point that you need it to be. And
Absolutely.
so thank you for that, Gavin.
Of
I
course.
believe we have a little bit of time left for Swamp Corner with Fia.
Yes.
Wonderful.
Today on Swamp Corner, I have for you the Alligator Gar, Atracosteus spatula. It is a fish, a ray-finned fish related to the bowfin. It is the largest species in the gar family. They are also euryhaline, which means they can tolerate a wide range of salinity tolerance. So, in my personal experience, I've seen them in freshwater, I've seen them in saltwater, I've seen them in a little mix of both. They are pretty old in fossil records, and not particularly the alligator gar, but just gars in general. Their existence can trace back to the early Cretaceous, which was over 100 million years ago, right, Gavin?
Yeah, so the Cretaceous was from more or less 120 million to 66 million years ago.
Okay, cool. Yeah. So yeah, gars are often referred to as primitive or living fossils, which, bleh, I don't like that word.
I agree, and I'm looking on my phone. I need to get better at memorizing what episode number was what. We have an entire episode dedicated to why the term living fossil is not good.
Yeah. But yeah, their common name came from their resemblance to the American alligator because of their broad, long snouts and sharp teeth. I would highly recommend looking up alligator gar. They are
They're really cool.
Pretty cool sight to see. Yeah, they also can get pretty hefty, pretty long. Anecdotal evidence has shown they can grow up to 10 feet, which for my metric people, that's about 3 meters. But yeah, I don't know how. I've never seen a 10-foot. I've never seen
that
one.
is bigger than I thought you were going to say.
Yeah,
that's a big fish.
Yeah. Oh yeah. And I know, like, I've heard people around here seeing like garfish pretty big. I don't know that I've heard of 10 feet, but definitely like within like 6 or 8.
Okay.
But yeah, this last part I would like to shout out Andy. He would like me to put in this little snippet about Gar Caviar, which apparently is poisonous to people because they have an ichthyotoxin, which I guess is toxic to humans. But they're close related bowfin fish. Their caviar, which is their fish eggs, is actually I don't know if fished is the right term to get fish eggs, but they are
harvested.
Harvested, yeah, they're harvested now and pretty valuable in Louisiana. So yeah, do not eat gar eggs. That would be bad.
Cool. Good alligator gar, I think, are really cool, and it's honestly just kind of a running theme that, like, for whatever reason, people like to name things that aren't alligators after alligators.
Yeah, that's weird.
Because like also around Louisiana and like the South in general, there's the alligator snapping turtle.
Yes.
Which does not really look like an alligator much. It's just its shell is a bit spikier than like the common snapping turtle. So they're like, spiky means old, and alligators are old. Sure. There's also several different kinds of lizards that are not related to each other called alligator lizards. Yeah.
That's very confusing.
Yep.
But yeah.
Well, wonderful. Is that it, everybody?
Yeah.
I believe so.
Awesome. Well, this has been episode 4 of I Wish You Were Dead, a podcast about things that used to be alive. That was Fia and Gavin. My name is Mike, and I'll be taking the wheel next week. But until then, take care, everybody.
This episode of I Wish You Were Dead was written by Gavin Davidson and hosted by Gavin Davidson, Mike Bryson, and Fenella Campanino. It was sound edited by Mike Bryson and edited for YouTube by Gavin Davidson. Special thanks to former guests of the pod and to listeners like you.